the next rule that we have for the array reference is this L producing ID. So, for this L producing ID, the situation is very simple. So, this L dot place, so this means that that L that I am talking about, it is a single variable, it is not an array. So, this L dot place equal to ID dot place and L dot offset is null. So, this is made null, so that it is it will mean that I will have I will be having simple, in fact this quote is not necessary. So, it should be like this, that L dot offset equal to null. So, that means it is a simple variable. Now, let us look into this particular rule. So, this is array specific. So, this is L producing E list bracket close. So, how are you going to handle this? L dot place is new temporary, L dot offset is new temporary. So, this for this L I need to calculate the, I need to generate the place and offset. So, they are generated in two new temporaries, and then L dot place. So, so L dot place that holds the constant part of the array. So, if we look into the rule that we have seen previously. So, this L dot place it holds the E list dot place is the variable holding the value for the index expression. So, at any point this whenever it is done, so L producing E list. So, L L dot place should hold the name of the variable, which may be an array, and L dot offset will be the offset within the array. So, you see that this L dot place is new temp, L dot offset is new temp. Now, after that, so this I have to generate this piece of code, that is this new temp equal to the constant part of the array. So, that is so that will have this base plus etcetera etcetera. So, that constant part of the array that is available in the symbol table. So, E list dot array holds the E list dot array holds the name of the array, and then this so for that the constant part will be retrieved from the symbol table, and that will be assigned to L dot place, and L dot offset will be equal to this E list dot place multiplied by width of E list dot array. So, this whatever be the E list dot place, so it has got the offset part. So, that multiplied by width of this individual array elements for this particular dimension. So, they will be multiplied, and that will be given to L dot offset. So, this way it will work. Now, for a multi-dimensional array, so I will have to do it like this, that E list producing E list 1 comma E. So, however, so then this t equal to new temp. So, this gives me a new temporary variable, and m. So, this holds that this is the new dimension that I have got. So, E list 1 dot dimension. So, that was the dimension that we were considering previously. So, which was this part. So, for example, if you have got an array access like say x plus y comma z into w, as I was talking about. Now, at this point this x plus y, so this is available in E list 1 part, and this is in E. Okay. Now, from that I have to get this E list. So, E list is for this entire thing. So, how to get it? So, t equal to new temp. So, m, so dimension that I am talking about is previously whatever was the dimension of this E list 1 dot dim. So, this is E list 1 dot dimension was 1. Now, this is the second dimension has been added. So, this becomes equal to 2, and then we emit this particular code that t assigned as E list 1. So, t is a temporary here. So, E list 1 dot place multiplied by limit of E list 1 dot array for dimension m. So, we assume that there is a function limit that will search the symbol table and tell us what is the size of the array, what is the dimension of the array in the mth order. So, if it is a two dimensional array, so initially m is equal to 1, after that m equal to 2. So, this limit will tell in each dimension what is the maximum value or maximum index that the array can take. So, that will give us this thing. Then we emit this particular code. So, this t assigned as t plus e dot place. So, that is the offset that has been calculated into this e. So, that will be added, and then E list dot array for no, so for this E list, so this is the array, the array name is same as the E list 1 dot array. So, that is taken, and this E list dot place equal to T and E list dot dimension equal to M. Okay. So, this is done this way. Now, the next rule that I have to consider is E list producing ID within bracket E. So, this is basically I have got an array ID within bracket E, and either it is bracket close, or other situation is ID within bracket E comma the next dimension say is another E. So, like that. So, here it is. So, what we do, we break at this point, and we call it E list. So, this E list producing ID open parenthesis the open square bracket E. So, like that. So, in that case E list dot array is equal to ID dot place, E list dot place equal to E dot place, and E list dot dimension equal to 1. So, that is the first dimension. So, E list dot dimension equal to 1. So, this way I can have this semantic action for the arrays. So, it is a bit cumbersome, but once you get habituated to this, then you will be able to understand that okay, it is very simple, it can be the translation can be done very efficiently. So, here is an example. So, suppose I have got this in this example. So, there are 3 arrays x, y and z, and their dimensions are x is of dimension d1 by d2, y is of d3 by d4, and z is d5 by d6, and each element is of width w. Okay. So, width of each element is taken to be same, and that has to be because I am doing some arithmetic operation, assignment etc. on this. So, that has to be done. Now, suppose the statement that I have to for which I need to generate the code is this one, that xij equal to yij k plus z k l. Okay. So, on the left hand side as well as on the right hand side we have got arrays, okay, and the arrays are of 2 dimension, each of them is a 2 dimensional array. So, the first assignment, so for the first step that I have is S producing L assigned as E, where the L should generate the left hand side, that is this one, and E should generate this right hand side, this whole thing. So, let us see how L generates this left hand side. So, we have to start with this production E list bracket close. So, in fact, the parser, so if you give it to the parser, so it will generate the parse tree like that. So, for the sake of our practice, so we have to we see that we will do like this, that L produces E list bracket close. So, that is taken, and then this from this so this E list is the last part. So, since it is E list bracket close, so this is basically this part J bracket close part, this is the J bracket close part. So, I have to generate this part, the first part, and for doing the first part, so I have to have this E list comma E. So, that from E I can generate this I, sorry, so from this E I can generate this J part, from E I can generate this J part, and from this E list comma E. So, from E list comma part, so I can generate this part. So, that will be the E list. So, that should be E list comma E. So, like that. Now, from this E list I have to generate this x bracket start I. So, comma is done. So, I have to generate from this E list x bracket start I. So, that is ID bracket start E. Okay. Now, from E I come to L, and from L I come to ID. So, that is I, fine. Now, for this J part, so that has so I was stuck at this point E list comma E, and then from E I have to generate L, from L to ID, that is J. So, that completes the parse tree for the left hand side. For the right hand side, so this is an E, this whole thing is E, and this is a sum of 2 expressions. So, the first rule that I should have is E plus E. So, that is done here. So, this is first E, this is plus, this is second E. Now, how this first E is going to be generated? So, again this is an array reference. So, I have to go by this E producing L, and L, as I said that whenever there is an array. So, the first rule that I have is by this one E list bracket close. So, it is E list bracket close. So, this whole thing is E list, this whole thing will be E list and then the bracket close, and after that from this E list I have to generate this part comma and k. So, that is done here E list comma E. Okay. Now, from this E list I have to generate y bracket start I plus j. So, that is id bracket start E, okay, and this id will give me y. Now, this E it is giving me E plus E. So, this I plus j, I have to get I plus j. So, it gives E plus E, then this E gives me L, this L gives me id which is I, and this E gives me L which is id which is j. So, this part is done. So, I plus j comma. So, y I plus j comma, up to that much we have seen how the parts tree has been made. For the k part, so this E producing L, L producing id, and that gives the k part. So, that finishes this one, okay, and plus is already done. Now, I have to do for this ZKL. So, ZKL again the same thing. From this E, if you want to come to an array, the first rule is this E producing L and then L producing E list bracket close. So, E list, this whole thing is E list, and then the bracket close is separate. Now, this E list I have to break it into E list comma E, where E will give me this L part and E list will give me this part, and comma will be there. So, it is E list comma E. Now, this E list will give me id. So, this should give me this id, that is this Z, this is the id part, then this is bracket start and E giving me L, L giving me id, which id is k, and this id is Z. So, this way I can generate this part, and then this L part. So, this can be generated by following this E producing L producing id, and this id gives me L. So, that ends the understanding of the construction of the parts tree. So, one thing is that you see this is automatically done by the parser. So, you do not have to do it by hand, but just for our code generation practice and understanding the process of code generation. So, we are doing it manually by hand. Okay. Now, how the code is actually generated. So, after that what I have done is that I have marked the reductions in the reverse order. The first reduction that will be done is this one. So, this L producing id. So, that is the first reduction that the parser can do. So, this is numbered as 1, then this one number 2. So, once 1 and 2 are over, so I can do this reduction. So, that is 3. After that I can do this reduction, this is 4, then this one 5, this one 6, this one 7. I cannot proceed further. So, I have to come down, see where is 8. So, this is my 8. Once this is done, this is 9. So, this is 10, this is 11. When 9 and 11 are done, so I can do this 12. When 12 is done, I can do this 13. Once 13 is done, I cannot proceed further. So, I have to come down and see at this level that I can do this reduction L producing id 14. Then after that, so do this reduction, so 15, and after 15, so I can do this reduction. So, this is so this reduction is number 16, this reduction is number 17, this is 18. So, up to that is done. Now, again I have to fall back and see what is the next possible reduction. So, this is this one L producing id, so number 19, then E producing L 20, then this reduction 21, then L producing id 22, E producing L 23, then this is 24, this is 25, 26, 27, 28. So, this way we number them, so that we can understand like how this code will be generated for this individual statements. Okay. So, this is the action that goes on as we proceed through this parts tree and try to generate the code. So, at step number 1, so at step number 1 is this one, So, this L producing ID, and the rule for that is L producing ID. So, L dot place is ID dot place, L dot offset is null. So, that is done here. So, L dot offset is ID dot place, that is I, and L dot offset is null. So, no code is generated. Now, step number 2, E producing L. So, E producing L tells that E dot place will be L dot place. So, L dot offset is null. So, in that, so I will have E dot place equal to L dot place. So, this E dot place equal to I. Now, step number 3. So, step number 3 is this one. So, this is E list producing ID within bracket E. So, let us see what is the corresponding action. So, this is the rule. So, it says that E list dot array will be ID dot place, E list dot place will be E dot place, and E list dot dimension will be 1. So, let us see whether that has happened here or not. So, E list dot array equal to x, okay, that ID, E list dot place equal to E dot place, that is I, and E list dot dimension equal to 1. So, that has been done here. Now, comes to step number 4, this L producing ID. So, L producing ID, again the same thing, that L dot place equal to ID dot place. So, L dot place equal to j, L dot offset equal to null. Now, at step 5, so E dot place equal to L dot place. So, E dot place equal to j. Now, step number 6 is again, so this one E list comma E. So, that reduction is done. So, for that E list comma E. So, this is the rule. So, I have to get a new temporary variable, number of dimensions are to be incremented, then it will generate this type of code. So, what is done here, you see at step number 6 is E list dot array is the name of the array coming from E list 1 dot array. Now, E list dot place equal to T 1, so new temporary, and this dimension increases to 1 more, that is 2, and then T 1 equal to I into D 2. So, that is the size of the second dimension. So, I into D 2, then T 1 equal to T 1 plus j. So, that is T 1 plus the offset part E dot place. So, that will be added. So, this code will be generated, and then at reduction number 7, so L producing E list bracket close this open close parenthesis. So, E list bracket close. So, this one, this L dot place new temp, L dot offset new temp, then it will emit this piece of code. So, this L dot offset, L dot place is T 2, L dot offset equal to T 3. Now, it generates the code that T 2 equal to C of x and T 3 equal to T 1 into W. So, T 1 it has calculated the offset. So, that multiplied by the size in that dimension, that is W. So, it is T 1 into W. Then at step number 8, reduction number 8. So, it will be at reduction number 8. So, it is L producing ID. So, it will be doing it this way, that L dot place equal to I and L dot offset equal to null, no code is generated. So, next code is generated somewhere at this point, at this reduction number 12. Okay. Now, so you can trace through this code generation process. So, we will do some bigger exercise later once we come to the end of this chapter, but ultimately we have got this piece of code generated. So, we have got this T 1 equal to I into D 2, T 1 equal to T 1 plus j, then T 2 equal to constant part of x, T 3 equal to T 1 into W, then T 4 equal to I plus j, T 5 equal to T 4 into D 4, T 5 equal to T 5 plus k, then T 6 equal to constant part of y, then T 7 equal to T 5 into W, then T 8 equal to T 6 T 7. then T9 equal to k into D6, T9 equal to T9 plus L, then T10 equal to constant part of Z, T11 equal to T9 into W, T12 equal to T10 T11, T13 equal to T8 plus T12, and T2 T3 equal to T13. So, let us try to correlate this code with the example that I had, that we had taken. So, it is Xij plus Yij. So, we have got this X, the example that we have taken is X ij equal to Y I plus j k plus Z k L, and the dimensions are X is of dimension d1 d2, Y is of dimension d3 d4, and Z is of dimension d5 d6. Okay, so so let us try to see whether this particular code is being generated Xij equal to Yijk plus Y plus jk plus Zkl, whether that is generated or not. So, this is I into d2. So, I into d2 is for the first dimension. So, it is doing like say I into d2, and then it is doing T1 equal to T1 plus j. So, T1 equal to, so T1 was I into d2 plus j. So, that is giving me the offset of this ij, and T3 T2 now equal to constant part of x, and T3 equal to T1 into W. So, that gives me the actual offset. So, this T2 contains the base part, and T3 contains T2 contains the constant part of the array reference, and T3 contains the base the offset part. And at the end you will notice that I am doing like T2 T3 assigned as T13. So, T2 T3, so it is Xij ultimately. Okay. So, if you look into this, so this Xij equal to something. So, this Xij is turning out to be this T2 T3. Now, for the next part, so Y I plus j k. So, Y I plus j k, for that, so this in T4 it is computing I plus j, then that is multiplied by the dimension of the second array. So, that is D4 in the second index. So, it is D4, then T5 equal to T5 plus k. So, this is the second index that I have. So, it was x y I plus j k. So, I plus j we have computed the offset. So, with that the offset for k has to be added. So, that is done here, and T6 is the constant part of y, T7 is the variable part of this, the offset part of y axis. So, this is T7 equal to T5 into W. So, ultimately I have got T8 equal to T6 T7. So, this T8 contains the this part. So, y I plus j k part. Now, this ZKL part. So, for that T9 equal to k into D6. So, D6 is the dimension of the third array in the second index. T9 is T9 plus L, and then T10 is the constant part of Z, T11 is T9 into W, then T12 is T10 T11. So, that way I have got this in this variable T2. So, I have got the array element copied. Then T13 is T8 plus T12. So, T8 was having this T6 T7, and T13 is having T12 is having T10 T11. So, they are added. So, we get T13 equal to T8 plus T12. Ultimately, T2 T3 assigned as T13. So, this is holding the value of T13. So, T13 is having the T8 plus T12. So, this right hand side of the expression. So, this whole thing is available in T12. So, that is added with T8, and T8 was holding the first array axis T6 T7. So, they are added and then that is assigned to the array on the left hand side T12, T13. Okay. So, this way we can generate the code for the array elements. So, it is a bit cumbersome, but so if with a little bit of practice, so you will be able to do it by hand. So, we will also try to do a few some exercises in the class towards the end of the chapter. Next, we will be looking into translation of Boolean expressions. So, Boolean expressions are something very important, because many a time we have got these Boolean variables and these Boolean controls are there, like say if then else type of control, while loop type of control. So, like that. So, we have got these Boolean expressions. So, they form part of this control statements in a programming language. So, for doing this translation of the Boolean expression, so we will be doing it like this. So, we will assume that there is an attribute b dot true. For any Boolean expression b, it will have an attribute b dot true. So, that defines the place and control that control should reach if b is true. So, in the program execution, if this is a portion of the program, and at this point suppose I am evaluating this is here I have got some code which is evaluating the Boolean expression b. As I said that these are normally part of if then else or while go to statement. So, if this b condition is true, then where to go? Okay. So, maybe if it is an if then else statement. So, if some x is greater than y, then S1 else S2. So, that means if this is my b, okay. So, if b happens to be true, then I should jump to the portion of code where S1 is being executed. So, S1 has been coded. On the other hand, if b is false, in that case I need to jump to another piece of code which is S2. So, that way with b, the Boolean variable b, so we assume that we have got for the Boolean non-terminal b. So, we assume that there are two attributes b dot true and b dot false, while b dot true defines place the control should reach if b is true, and b dot false will define place where control should reach if b is false. So, the grammar that we will be considering is this AND OR grammar. So, AND or NOT, these are the three operators. So, b or b, b and b, not of b, within bracket b. Then we also have got this relational operators id, relope id. So, you can have the relope. So, this is the relational operator. So, all the relational operators like greater than, less than, so greater or less or equal, greater or equal, equality. So, all of them we club together and call them the relational operator relope. Now, this relope operator, so this will be, so this so we are only only allowing this id relope id. So, you can only write like x greater than y, like that. So, we cannot have expression like x plus y greater than z into w. So, that type of expression, so we are not allowing in this particular grammar. Okay. So, that can be done, but for the sake of our understanding, because we do not want to bring this arithmetic operators into consideration. So, they are not taken here. And then since it is a Boolean expression, so we have got two constant identifiers, true and false. So, they are also part of the grammar. So, this is the grammar that we have, and then we will see in the next class how to have this code generation for the Boolean expressions.